Hello everyone, welcome to my channel. In this lecture, we will discuss about the pressure swing adsorption process. The previous lecture was related to the temperature swing adsorption process. Now in this lecture, we will discuss the pressure swing adsorption process for the purification of air. So first of all, we will open the Aspen Adsorption. We will go to the component list and we will go to the configure property. Click on configure property. Click using Aspen property system. So here you can use edit using Aspen property or this one or this one. So if you use edit using Aspen properties, you will go to the Aspen plus, and from the Aspen plus you will add your component to the Aspen adsorption. Now I'm using this use property definition file. Click on this one, click on browse. So I will select my uh, file, which is the Aspen adsorption, and from this Aspen adsorption, you can open, you can OK, again OK. Now click on default and add your component. So it is added, click on OK. After that, we will go to the Flowsheet window, process Flowsheet window, and here we will make our process Flowsheet. Feed, product, product, feed well, product well, waste well, bottom tank void, top tank void, bed, adsorption column. And this is a gas dynamic model. So this is B1, well, bottom void, top void, waste wall, waste stream, product wall, and product stream. Right click on this one, rename block. This is speed. You can also rename like control M. This is the feed well. This is the bottom tank. This is bed, top tank. This is the waste wall, waste. This is the product wall. This is the product, product. Now connect your material stream to the bed. So here we will go to the connection, gas material connection. Here, so cut this one and another stream. Okay, rotate this one, this one. Okay, now double click on feed, click on specify. It consists of 79% nitrogen, 21% oxygen. The pressure of the fluid is 3.045 bar. Close this one. Go to the waste stream, double click on it. The waste stream pressure is 1.013, 1 atm. Close. Go to the product stream, click on specification. The product pressure is also 1 atm. Close this one. Now go to the bed. Okay, now go to the bed, and this is the number of layer. One bed type is vertical. Spatial dimension is one dimensional. There is no heat exchanger. Click on this one. This is the general UDS1, number of node 20. Material and momentum balance. Material balance is convection. Momentum balance is Argon equation. It can be Argon or Karman-Kuzny or some other equation. The model, the kinetic model assumption, the film model assumption is solid. It can be lump resistance. Mass transfer coefficient can be constant or Arrhenius or estimated. The isotherms can be Langmuir-friendly, extended Langmuir-friendly. Isotherm can depend on concentration or partial pressure. For gaseous case, it depends on partial pressure. For liquid case, it depends on the concentration. Energy balance can be isothermal, non-isothermal. The heat transfer to the environment, solid phase heat capacity, form of heat transfer coefficient, etc. Specify. So here you can see the property of the adsorption column, the height of the column, the diameter of the adsorption column, interparticle, intraparticle voidage, adsorbent particle density, the shape factor, radius, mass transfer coefficient, isothermal parameter, etc. Okay, this is the initial. This is the results initialize. So this is open. So I have file related to the adsorption column. I will open this one, that one. Okay. Okay, so this is not open the file. Okay, open. Open the file. It will take some time. So here, you can see the discretization method, number of node, momentum, kinetic model, isotherms, is friend like the isothermal dependence is partial pressure, energy balance, non-isothermal with no conduction, adiabatic constant. So the specification, the height of the column, diameter of the column, etc. Initial 0, 0, initialize. Now double click on bottom tank, click on initialize, click on top tank, click on initialization. This one run is complete. Okay, complete. Now we will make a breakthrough curves. For example, breakthrough curve, breakthrough curve, and this is go to this one, and this is suppose the solid loading curve. Okay. So now we will go to the cyclic organizer, go to tool to make the pressure swing adsorption cycle. So go to the tool, go to the cyclic organizer. There will be two steps. One will be for adsorption, the other will be for desorption. So this is pressure swing adsorption process. The first step is adsorption, and the adsorption step is for 1000 second, and go to the manipulated variable. The feed well active specification is 1. The the product well flow rate is given to us. Product well flow rate is given to us. That is 5.2 multiplied by 10 raised to the power minus 9. Okay. And the waste wall is closed. Waste wall is closed. Okay. Now go to step, add an insert step. Click on this one. Click on after. Click on yes. Okay. Now go to control. This is the second step. This is step 1. This is step 2. This is the step number 2 is desorption. And the desorption is after adsorption, and the desorption step is also for 1000 second. Click on manipulated. And during the desorption process, the feed and product wall will be closed and the waste wall will be open with constant CV value. So the feed wall active specification will be 0. The product wall will, I will delete this one. The product wall active specification, the product wall will be closed and the waste wall will be open with some CV, with some constant CV. Okay, waste wall CV value is given, and it is 6 multiplied by 10 raised to the power minus 6 kilomole per second into bar. Okay, so this is step 1, step 2, and this is cycle, maximum cycle 1 or 2 or some, you can also add 20, 30, etc. So maximum cycle is suppose 1, and cyclic steady state testing. Click on generate cycle. Step 1, step 2, etc. Okay. Now go to the dynamic mode. Click on run. So here you can see the simulation message. Okay. 1000 second. Absorption is completed. Now this will be the desorption step. So the run is complete. 1000 seconds for absorption and 1000 seconds for the desorption. Now here you can see run is completed. And cyclic steady state tolerance is this one. Here you can see this is the desorption cycle. This is cycle 1, step number 2, desorption. And this is adsorption. Cycle 1, step 1, adsorption. Okay. Now go to the plots, like go to the Flowsheet, go to the breakthrough curve. Okay. This is the breakthrough curve. So suppose I want to make the breakthrough curves about the product stream. So this is, go to this, double click on product stream, click on the result, nitrogen, oxygen. This is the time. So close this one, right click, zoom full, or you can this one, click on property, and suppose this is, I want this black one, this one, this one, this one, this one, and suppose this is the grid line and marker. The marker size is suppose 3, interval is okay. This one, and this is the x-axis, grid, map axis, all in one. You can okay, right click, property, one for each. Okay. Property. Go to the property, variable, grid. Okay, so here you can see various option. So 2000 seconds, so 200. Okay. Now I'm making some other plot, like go to this one, or here you can see this solid loading. Solid loading. So double click on this one. column, and this one, go to result, go to solid loading, nitrogen and oxygen at start of the column. Node 1 mean at the bottom of the column. Node number 10 mean middle of the column. What will be the nitrogen and oxygen loading at the middle of the column? And node number 20 mean the top of the column. So what will be the nitrogen and oxygen loading at the top of the column? So right click, zoom full, zoom full. This one, this one, full. The time axis, suppose I want it 200 second. Okay, go to property. This one to black. This one, this one. This one. Okay. Map axis, one for each. Property, all in one. The property, line and marker. So this is all about that how the pressure swing adsorption column is working. Thank you very much for your attention. If you are new to the channel, please like and subscribe.